Find the arithmetic mean of all the 3-digit palindromes. Arithmetic mean of all 3-digit palindromes. Okay. Well, obviously we want two things here. We want the sum of all the palindromes and to count how many palindromes there are. I suppose each of these palindromes will consist of, well, there'll be a one-to-one correspondence between the palindromes and all 2-digit numbers. Is that right? If I have a 2-digit number, AB, I map that to the palindrome ABA. And vice versa. I want to make sure I don't do something silly here, like I'm not double counting or anything like that, right? If I take an arbitrary palindrome, okay. So yeah, like the middle digit's allowed to be 0. And in a 2-digit number, the second digit's allowed to be 0. The first digit is not allowed to be 0. But in our 2-digit numbers, the first digit is not allowed to be 0. So how many 2-digit numbers are there? I can choose any of 9 digits to go there and any of 10 digits to go there. So there are 90 2-digit numbers, which means there are 90 3-digit palindromes. Now I need to add all the 3-digit palindromes. Well, if I add all 2-digit numbers, that gives me 1/10 of the sum. Well, that gives me the sum of all the palindromes where I drop the ones digit and then divide by 10, something like that. Okay, so the sum of these 2-digit numbers, this is the sum, 10 plus 11 plus ... plus 99. This is equal to 10 plus 99 over 2 times 90, which is 109 times 45. This is 110 times 45 minus 45. So that's not going to be easy to do either. Let's just multiply these using standard whatever. 5, 4, 4, 5, 0, 6, 3, 4. Okay. 5, 0, 1, 9, 4. Okay. So 4905. That's the sum of all 2-digit numbers. Okay. So this means the sum of all numbers of the form a, b, 0, that's equal to 4, 9, well, over the 90 of them that I want, 49050. And so here I'm missing the sum of the numbers 1 to 9. That's 10 times 9 over 2, which is 45. And so each of these numbers, so the number 1, I missed it. So I missed the number 1, by replacing a 1 digit with a 0 digit, I missed it for all 10 allowable values of b. So I have to multiply this by 10. This is what's missing from that sum. Okay, so 49050 plus 450 that's the sum of all the palindromes, and I need to divide that by 90. So my answer is 49500 divided by 90. It's 4950 over 9. Let's just do some long division. Uh, 5, 45, 45, 50. Okay, so my answer is 550. That is the arithmetic mean of all 3-digit palindromes. Maybe I could have done this a little bit more. I could have been more organized about this, certainly. I mean, it's clear that there are 90 palindromes. This is a bijection. So for any 2-digit number, of which there are 90 of them, there is a 3-digit palindrome. So then, I mean, to get the total sum, maybe this a smarter way of doing it is, this is equal to 101A plus 10B. And I want a sum of that, 101A plus 10B, as A you could even write it as a double sum. A goes from 1 to 9, and B goes from 0 to 9. And yeah, maybe that's a sort of a nicer way to work this out. Keeping track of the fact that you have this double sum. This does not depend on B, so when you sum that component over B, it gets multiplied by the number of terms here. And then this one, this is easy to compute. The sum, this is just the sum of the first 10 numbers multiplied by 10. Going from 0 to 9. And then that's going to be an expression, and that won't depend on a. So when you sum that over a, you have to remember to multiply it here by 9. I'm not going to work through this method of doing it like that. I think I didn't end up double counting or over counting things by this. It was definitely very cluttered, the way that I organized this in my head. But my approach here, the idea, I think works. Find the sum of all palindromes and the number of palindromes and then divide them like that. I hope that's the correct answer, but I'll let you know what the right answer is if this doesn't work out. Thanks for watching.